Hi guys, in today's video, I'm going to be continuing with the AP Calculus BC syllabus. I'm going to be discussing some questions on particle motion in parametric equations. So let's get started. So the first question says that the position can be written as x of t is equal to 2t cubed minus 15t squared plus 36t plus 5. So this is the position. And then y of t is t cubed minus 3t squared plus 1, where t is greater than or equal to 0. For what values of t? So for what values of t is the particle at rest? So this is the position of the particle. They've given x of t comma y of t. And they're asking us for what values of t is the particle at rest. So the first thing we need to know is the particle is at rest whenever the velocity vector is equal to 0, 0. So it's at rest whenever that's the value of the velocity vector. So what we can do is we can derive the position to get the velocity in terms of t. So that would give us 6t squared minus 30t plus 36, comma 3t squared minus 60. So this is our velocity vector in terms of t. So now we have to find out the value of t which makes this and this 0. So let's go about solving this first. So 6t squared minus 30t plus 36 is equal to 0. And if we solve this quadratic equation, we get t is equal to 2 and t is equal to 3. Similarly, if we solve this, we get 3t squared minus 6t is equal to 0. Solving the quadratic gives us t is 0 and t is 2. So now that we have these values of t, we have to find which value is common to both. The only value that's common to both is t equals 2. So this is the time at which the particle is at rest. Now let's look at another question. They've given us the velocity vector, which is 3t squared minus 4t, comma 8t cubed plus 5. So at t is equal to 0, the position of the particle is 7, comma negative 4. So we have to find the position at t is equal to 1. So you can solve this question in two ways, and I'm going to be discussing the first way. So then what we can do is we can first write out the position vector. So the position vector would be the integral of the velocity vector. So that would be t cubed minus 2t squared plus c, comma 4t to the power of 4. Sorry, 2t to the power of 4 plus 5t plus c. So this is the position vector. And now we know that at time is equal to 0. So t cubed minus 2t squared plus c. So at t is equal to 0, this is equal to 7. This is equal to 7. So what we can do is we can plug in 0 into this equation. So 0 cubed minus 2 into 0 squared plus c is equal to 7. So we know that c is equal to 7. Now let's look at it for the second one. So 2 into 0 to the power of 4 plus 5 into 0. plus c is equal to -4. So then c is equal to -4. So now that we know both our values for c, we can write out the position vector again. So it's t cubed minus 2t squared plus 7, comma 2t to the power of 4 plus 5t minus 4. So this is our position vector. Now what we do is we plug in t equals 1 and that would be our answer. So 1 minus 2 plus 7, which is 6. 2 plus 5 is 7, minus 4 is 3. So 6, comma 3 is our position vector at t is equal to 1, and that's our final answer. Okay, that's it for today's video, guys. In today's video, I discussed 2 questions on particle motion in parametric equation. Hope you all have a great day, and please consider liking and subscribing. Thank you.